In this problem, we have a worker pushes a 1,500 Newton crate with a horizontal force of 345 newtons, a distance of 24 meters. We assume that the coefficient of friction between the crate and the floor is 0.22. We want to first find out how much work is done by the worker on the crate, then find out how much work is done by the floor on the crate, and finally what is that net work done on the crate. We start by drawing our free body diagram. So we have four forces acting on this crate. We have, of course, the gravitational force acting downward. We have the normal force since we're on the surface acting upward. We have an applied force, which is given to us to be 345 newtons. And we have the friction. Because it is moving, it is kinetic friction in this case. Next, we write down our givens. We are told that the gravitational force of the crate is 1,500 newtons. So that is not the mass because it's measured in newtons, not kilograms. We're also told that the applied force by the worker is 345 newtons. And we're given that the distance it travels is 24 meters. Finally, we were given that coefficient of kinetic friction, which is 0.22. Now, for the first part, we want to find the work done by the worker. So our equation for work is force times distance times the cosine of the angle in between those two directions. So if we want to find the work done by the worker, we are looking for the applied force. I'll label this as FW, the work done by the worker. We are looking for the applied force because that's a force exerted by the worker. So we put our values in, and we have that the applied force is 345 newtons. It moves a distance of 24 meters. And now that angle, well, the direction of the applied force is to the right. And the direction that it moves is also to the right. So therefore, if they are the same direction, our angle is 0 degrees. So we solve, and we get the work done by the worker is 8,280 joules. So that's our answer for letter A. Letter B gets a little bit more complicated because it asks how much work is done by the floor on the crate. Well, there's really two forces exerted by the floor. There is the normal force and the frictional force. Now, the direction that it moves is to the right. And therefore, the direction of the normal force is perpendicular to the direction it moves. Hence, the normal force does not do any work. So if the direction of the force is perpendicular to the motion, it does not do any scientific work. So we only have to find the work done by the frictional force because the normal force does not do any work. So for letter B, we are looking for the work done by the floor. And again, that is Fe cosine of theta. In this case, our force is the friction, which we do not know. Nor does the applied force necessarily balance out the friction because we do not know if it's moving, that it's in equilibrium. We don't know if it's moving in constant velocity. So how do we solve for that force of friction? Well, first of all, the total force in the y direction is still equal to 0. That crate is not moving up or down. And so when we solve here, we've got two forces in the y direction. We have the normal force, which is up, and the gravitational force, which is down. So therefore, the normal force is the same as the gravitational force, which is 1,500 newtons. Now what we want to do is solve for that friction based off of the equation. The friction is equal to the coefficient of friction times the normal force. And we are given the coefficient to be 0.22, and we just solved for the normal force to be 1,500. And so our friction turns out to be 330 newtons. So now we can go back here, and when we solve, we have the friction, which is 330 newtons. The distance it moves is 24 meters. And now that angle. Now the direction of the friction is to the left, but yet the box moves to the right. They are in opposite directions, so the angle is 180 degrees. So same direction at 0 degrees, opposite direction is 180 degrees. We get the work done by friction to be a negative value, which is negative 7,920 joules. So again, the negative simply means that the force is in the opposing direction of the direction it moves, of the displacement. The final question asks, what is the net work done on the crate? So again, the crate moves to the right. So the normal force does not do any work because it is perpendicular to the direction it moves. The gravitational force does not do any work because it is also perpendicular to the direction it moves. So the only forces that do work are the applied force, and we know how much work that did, and the friction, we know how much work that did. So to get the net work, we simply add the work done by the worker, or the applied force, plus the work done by friction. Of course, keeping in mind the positives and negatives. So the worker was a positive 8,280 joules, plus negative 7,920 joules done by the friction, and we get the net work, which comes out to be 360 joules.